Hello, let's look at gas laws. Now, under gas laws, we are going to be looking at the behavior of gases. Now, remember in our topic on the kinetic theory of matter, we talked about matter as anything that has mass and occupies space. And it is made up of three different states, which is the solid, liquid, and gases. Under kinetic theory of matter, we are able to discuss the other two states of matter, the solid and the liquid state. Now, in this topic, we are going to be looking at the other state of matter called the gaseous state and the behavior of gases. Now, gas is a state of matter that is, or is a fluid form of matter that is made up of particles and molecules that are in constant random motion. Now, what do we mean by constant random motion? When the particles of a gas are heated, they move at a very high speed, colliding with each other and with the walls of their container. Now, this collision, as time goes on, causes what? A pressure to be exerted on the gases in the container. Now, this collision of the gas molecules is perfectly elastic, which means the particles collide with each other and return back to the original position as in the form of an elastic ball. So that is why we can say the collision of gas molecules or gas particles is perfectly elastic. Now, under gas laws, we're going to be looking at the relationship that exists between three basic variables that determine the behavior of gases. Now, these three variables are what we call pressure, temperature, and volume. So this is going to be our major focus in the study of gases. Now, the behavior of gases is determined by the relationship that exists between these three variables. Now, under gas laws, we have the works of various sciences, or different scientists have been able to come up with some findings and observations with regards to the behavior of gases based on these three variables. Now, we have scientists like Robert Boyle, Charles, Gay-Lussac's, Dalton, and so on and so forth. These scientists have been able over the years to come up with different discoveries and findings on the behavior of gases. So under gas laws, we're going to be looking at the works or the findings and discoveries of most of these scientists and what they were able to come up with in regards to the behavior of gases. Now, let's talk about one of the variables we mentioned here as the major variable that determines the behavior of gases, which is pressure. So we can say, so we have pressure as one of the basic major variables that determines the behavior of gases. Now, what is pressure? We can say pressure is the force per unit area. Force per unit area. So pressure is simply measured in unit called Pascal. Pressure is measured in unit called Pascal. Okay, it can also be measured in other units such as Newton meter square and millimeter mercury. Now, what is the relationship between these units? What is the relationship between these units? So we can say 1 Pascal, we can say 1 Pascal is equal to 1 Pascal is equal to 1 Newton meter square. Okay, 1 Pascal is equal to 1 Newton meter square. Okay, and 1 Pascal is equal to 760 millimeter mercury. 760 millimeter mercury. Okay, now 1 Pascal is also equal to 1 atmosphere. Of course, pressure can be measured in atmosphere. And we have one standard atmosphere, atmospheric pressure. One standard atmospheric pressure, which is 1 atm, is equal to pressure exerted by a gas at 1 atmosphere. Okay, so we can have it as 1 standard atmosphere to be equal to 760 millimeter mercury. So that is the relationship between 1 atmosphere and millimeter mercury. Of course, 1 atmosphere is equal to 760 millimeter mercury. And also 1 atmosphere is equal to 101,325 Newton meter square. It's equal to 135 Newton meter square. So that is the relationship between the different units of pressure. Now let's talk about the other variable, which is temperature. Let's talk about the other variable, which is temperature. Now, temperature is measured in unit called Kelvin. That is the SI unit of temperature, degree in Kelvin. Now, we can also measure temperature in other units, such as the degrees Celsius. So, we have 0 degrees Celsius to be equal to 273 Kelvin. So, 0 degrees Celsius will be equal to 273 Kelvin. Now, in solving questions based on gas laws, it is important that we work with the standard unit or the SI unit. So when the temperature is given to you in degrees Celsius, you try as much as you can to convert to Kelvin by adding 273. If I have, for example, 27 degrees Celsius, you simply convert it to Kelvin by adding 27 plus 273. This will give us 300 Kelvin. Okay, so it is important to work with the standard unit of the different variables. Now we have the last variable we'll be looking at is volume. So we have volume here in the course of the topic. Our volume will be measured in either centimeter cube or dm cube. Now what is the relationship between centimeter cube and dm cube? So we have 1 dm cube is equal to 1000 centimeter cube. 1 dm cube is equal to 1000 centimeter cube. So that is the basic relationship between this dm cube and centimeter cube. These are the three basic parameters we'll be looking at and the relationship between them in the course of this topic. Now with this, we'll come to the end of this class. In our next class, we'll be looking at some of the gas laws and we will begin with the Boyle's law. So I hope to see you in that class where we will go in details to talk about what the great scientist Robert Boyle discussed or explained with regards to the behavior of gases. So I want to say bye for now.